This is the last video we're going to have over regression, and in this video we're going to look at how to add categorical variables to your data. So let's get my pen up working here. There we go. So as it says, using categorical variables in regression. So far we've done quantitative, right? Things that are numbers with units of measurement. So now we're going to see how to add categories like male, female, first year, second year, third year students, and so on. So as it says here, to use categorical variables as predictors, as x's, in your regression model, you're going to have two choices here. Okay, so here are two choices. The first choice. So choice number one, do individual regression models for each category of the variable. So you do individual regression models for each category. This is the easiest way, but it's actually not the best way. That's usually the way things work out, right? The easiest usually aren't the best. So we'll do that first, see it's relatively easy, we'll see how to do that. Then we'll do the better way. The better way, the second choice, the better way of doing it is to use indicator variables. Indicator variables like Boolean variables, just sort of zeros and ones. That's what indicator variables are. It's either 0 or 1. So what we're going to do is we're going to use some data from Minitab. So let's get it up here. So we're going to use the hot dogs data set. Okay, remember in hot dogs, there are actually three variables. One variable is calories. We're going to use calories as our y, as our response, the calories in a hot dog. Then we've got two other types of variables. We've got sodium. So actually, we've got two x's here. We got predictors. We've got sodium, which is just a regular quantitative variable. So you got another x, which is sodium. But we've also got a second type of x, which is type, which is categorical. So type is categorical. We have three types: type 1, 2, and 3. Type 1 is beef, type 2 is meat, and type 3 is poultry. So sodium here, we'll say, is just quantitative numbers. So that's nothing new about that. Okay, so I'm going to reproduce this plot we have here. So the plot is easy enough. If we get Minitab over here. Oop. There we go. It's small again. Don't want to make it big. So I already have the hot dog data up here. Type 1, 2, and 3. The beef, the meat, mystery meat, and the poultry. Calories and sodium are quantitative variables. And we say we want to do a graph, do a scatter plot. So we're going to do graph scatter plot with groups, because you're going to use the symbols. So we're using the calories as the y, sodium as one of the x's, but now we also want to include type. That's going to be another x. So there's our plot. So we can see type 1, where the beef hot dogs are. Type 2, we can see the red where the meat hot dogs are, and type 3 we see the poultry. So that's the plots we have here on the handout. So now you can see basic things here, right, in the plot. We can see that most of the type 2, the meat, are up here, but they have one outlier out here, right? So an outlier, it seems to pretty much follow the trend. It may be slightly influential, but it's not that influential. For the meat, for the beef, the black dots, they're similar. They're up here, a little bit of curve. So maybe those two are influential, but they're sort of with the meat as well. The 1 and 2 are together, while 3, the poultry, are kind of down here in the graph, right? So obviously lower down, which means on average fewer calories. And it's harder to tell with the sodium where they fall. Maybe a little higher sodium on average. It's kind of hard to tell, but definitely lower calories. Okay, so that's the basic plot of the data. So the first choice, if we're going to do regression on this data, is, like I said, do individual regression models for each category. So what you're going to do is you first create individual columns for each category by copying and pasting the data. Or there's also in Minitab at least something called unstack. We can unstack the data, where that'll create the columns for us. Then do regressions on each category separately. So I'll do a regression for beef, a regression for meat, and a regression for poultry, for type 1, type 2, type 3 separately. Okay, so here, if we go to Minitab, okay, so here's our data. So notice, let's get the data back in. So we have type 1, scroll down here enough, type 2, and type 3. So what I can do is I can go to, let's see if it's data, the data unstack. So data unstack. If I do data unstack columns, I can unstack, actually I don't really need type, I need calories and sodium by type. Okay, so it's going to break up calories and sodium. So I'll have the calories and sodium for the type 1, they'll be in 2 columns. Then I'll have the calories and sodium for type 2, they'll be in 2 separate columns. And the calories and sodium for type 3, the poultry, they'll be in 2 separate columns. So I'm breaking it up by the type. And by default, what you probably want is going to put it in a new worksheet, which makes sense so you don't confuse it with the regular worksheet. So here's my data. Get back to my data, the other one. Come on. Here we go. Let's see if I can pull this up a bit. So here we have, so C1 and C2 in this new worksheet, that's the calories and sodium, but just for the black dots, just for the beef. 3 and 4 are the calories and sodium for the red squares. Those are for just the mystery meat, type 2. And then finally C5 and C6 was type 3, the poultry, the green ones. So that's what we're doing, breaking it up. So now we've got the black, the red, and the green separately. So now we can do regressions on those separately. And since here, if we're going to assume we're just doing straight lines, again, we could do fancier stuff, do squares and see if this makes sense and all that kind of stuff. But here we're just going to do simple linear regression for each of those. So all I'll do is just do stats, regression. I'm doing calories as my response, sodium is my predictor. And if I want, I could do all the graphs and everything too. But this will just give me the simple line for just the first type, which is the meat. So it gives me a bunch of information too, but if I go back up, there's the equation. Here's my equation for the meat line. And I can do the same thing for the other two too. I can go stats, regression. Now I want calories 2 by sodium 2. And this will be the regression equation up here for the meat. And I can do the same thing for poultry too. And one thing you can do also, I could graph these separately, right? Remember, if you go to stat, regression, fitted line plot, it'll graph the stuff for us. So let's just do that for 3. So for 3, I can do calories 3 by sodium 3. Linear. We want the, just in the fitted line plot. We don't want the graph. Okay, there we go. So that is just now, what I've done there is taken out, if I go back to the plot, I just took out the green ones here and did the line through those. So you could do that for each of them as well, if you wanted to. So these are really the green dots, just on their own scale, and then here's their line. So that's all we did. So all we did here is we got these 3 equations. So here is the model for beef. So this is the best fit line through just the beef only, the black ones, which is probably some line like that. Actually, what I should do, let me go ahead, I'll erase that. Let me make the colors match up. Let's make a black line for that. So that is the model for beef. Then you have a model for meat, get a little through there. There's the model for meat, so that'd be a red line. So that's going to be similar. Notice it's very similar. The slope's slightly different, the intercept's slightly different. But that's going to be for the, looks like the slope is slightly more, so it's going to be something like that, similar. And then we have the last one, if I scroll down a bit further. There we go, for poultry, right? Poultry's the last one. So for poultry, it's obviously different. Actually, its slope's pretty similar to the other two, 0.214, the other ones are 0.232 and 0.196. So all the slopes are similar, but the intercepts are definitely different, right? So it's here somewhere, the poultry equation. So that's what it's doing right now. And we get r squared for each, right? So we can see the r squared for poultry. The equation here, the r squared is 50.6%. So it explains about half the variation in the poultry values. For the meat, it's about 3/4 of the variation. The r squared is 74.5. And similarly, a little bit more for the beef. It's up to about 78.7% of the variations explained, the r squared. So you can do that. The problem is you lose power here because you're breaking it up. This is okay if you only have one variable like we have here, but if you have more than one categorical variable and you're trying to break it up by all the categories, it's very hard to get enough points left to get a good regression model. So you can do this if you only have one categorical variable. It's not the best thing to do, but that's one way to handle categorical variables. The other way to handle categorical variables, the better way, is to use indicator variables. So what you have to do is you have to take your original categories, change them to zeros and ones. So here the thing is, we have for our type, which is our categorical variable, we have 3 types, right? We have 1, 2, and 3, which are really beef, meat, and poultry. And the thing is, there's no order to those, right? I can't really, calling them 1, 2, and 3 doesn't make sense. If I just use 1, 2, and 3 here, that doesn't really make sense because it'll make them be in order, and here I want to make them separate because there's no really order to this. So what I have to do is I have to create some way to break them up. Indicator variables are a way to break them up. So what I'm going to do is create 2 indicator variables. I'm going to create indicator 1 and indicator 2. For indicator 1, I'm going to make beefs, the type 1, be zeros. I'm going to make type 2 and 3 be 1s. So that's breaking up the beef from the meat and the poultry. So beef is a 0, meat and poultry now 1s. But now after doing that, I have to break apart the meat and poultry. So the way I do that is indicator 2, I'm going to make beef and meat types 1 and 2 zeros. And I'm going to make type 3 poultry a 1. The reason now is, when I put the 2 indicator variables together, 0, 0 will indicate beef. If I have a 1, 0, that will indicate meat. If I have a 1, 1, that will indicate as poultry. And that will allow them to be their own models, but it will also allow the regression to fit better, have more points to look at. So that's kind of what we're gonna create the indicator variables, and then we're gonna see what happens. So notice here, since I have with 2 indicator variables, you can actually indicate 4 things, right? I could have a 0, 0, a 1, 0, a 1, 1, or a 0, 1, right? Here I'm not using that. I'm not using a 0, 1. The problem is actually if I use that, it would actually make the groups depend on one another, the beef, meat, and poultry. So actually you want to not use one of the groups, at least one of the groups. So if I had like 5 categories here, I would have to use 3 indicator variables, Because with 3 indicator variables, if I had 3 indicator variables, that's what, 2, 0, 1 for the first one, 2, 0, 1 for the next one, 2, 0, 1 for the next. I have eight different things I could write. Right, 0, 0, 0 through 1, 1, 1. There are 8 ways to do it. But actually, you can only use 7. So if I had a category that had 4 through 7 things, groupings, whatever it is, I could use 3 indicator variables for that. So that's kind of how it works with indicator variables. Here we only have 3 groupings, beef, meat, and poultry, so I can use 2 indicator variables. Because with 2 indicator variables, I can show anything from 1, 2, up to 3 categories. Okay, so let's go ahead and create the indicator variables like I have in this printout here. Okay, so I'm going to go back to the regular worksheets, if I can find that. I think it's here it is. So I want to create indicator 1. And I want to create indicator 1, and I want to create indicator 2. Oh, called it one name there. I thought it's separate cells. Let's go ahead and take this, put it in here, and then take it out of here. There we go. Indicator 1, indicator 2. So now what I do is I go to data, and I want to do some coding. So use data code. And here, since my categories are already numeric, I'm going to do numeric to numeric. If my categories were actually called beef, meat, and poultry, I'd have to use text to numeric. Change beef to 0s, change the other ones to 1s, whatever. But here, since they're 1, 2, and 3, I do numeric to numeric. So I'm going to take the types, store them in indicator 1. And I said first we want to take the 1s, the beefs, and make them 0s. I want to take the 2s and 3s and change them to 1s. So now that's what I have here. 2s and 3s are 1s, and 1s are now 0s. That's what we wanted, right? Beef to be, for indicator 1, beef to be 0, types 2 and 3, meat and poultry to be type 1 here, now for the indicator variable. So we used data code, and here we did numeric to numeric because our original values, these values here, were numbers too. If those were, like I said, if under C1 I had beef, meat, and poultry, I would have done text to numeric rather than numeric to numeric. Okay, so that is the first indicator variable. And now I want to go back, and second indicator variable, we said 0 was now beef and meat, and 1 was poultry. So I want to go to data code, numeric to numeric. And now the only difference is I now want 1 and 2 to be type 0 and type 3 to be 1. And I just want to make sure this is indicator, I want indicator 2 here to put it in. Otherwise I'll lose my indicator 1. So in indicator 2, there's going to be 1 and 2 are 0s, 3 are now 1s. So now 0, 0 indicates type 1, which was beef. 1, 0 indicates type 2, which was meat. And 1, 1 indicates type 3, which was poultry. So now I've got it set up like we had here on the handout. So now what we can do regression on this now. Just to show you, all I'm going to do is I'm not going to worry about best subsets right now. I'm just going to show you what happens when you do this. So I'm just going to do this stat regression. with calories as my y, sodium is 1x, but now indicator 1 and indicator 2 is my other 2x's. And we'll see what that gives us. And we'll see if that's actually the best thing. Actually, it's an okay thing, it's not the best thing. We'll see what the best thing to do is. So I'm going to do stat, regression. I want calories as my my y, sodium, indicator 1, indicator 2 is my x's. I'm not going to worry about the graphs right now because I'm just going to show you what the regression model looks like. We're not going to see if it looks random, all that stuff right now, but just seeing what happens. So here are the results, and here's the model. And that's what we have on our handout, this model up here and the p-values and stuff. So that's what we have right here. So it asks us, what is the model for just beef? Well, for beef, that is indicator 1, indicator 2 both being zeros, right? Indicator 1 and indicator 2 being zeros. So that means both these values can be zeros. So I put 0 in here. Notice all I have is just the equation without those indicators in there. So for beef, the model is calories equals 71.9 plus 0.212 times sodium. Now what about for meat? Well, for meat, we had what? For meat, it was 1 and 0, right, with the indicators. That was for meat. So that means for meat, we're going to have indicator 1 in there, but not indicator 2. So that means we had the calories is equal to 71.9 plus 0.212 times sodium. But notice we're going to have minus 1.82 times 1, if you want, minus 44.8 times 0, which goes away. Because over here we also had over here like minus 1.82 times 0, minus 44.8 times 0 for the beef, right? Those disappeared. We ignored those. So here I'm going to subtract 1.82 from the 71, right? So calories is going to be what? It's going to be, we'll take that away, it's going to go 70.08, looks like, if I take 1.82 away from 71.9 plus 0.212 times sodium. And finally for poultry, I think just about, let's scroll up a little bit. There we go. For poultry, well, poultry is 1, right? Both ones. So the calories is going to be 71.9 plus 0.212 times sodium. But now we have minus 1.82 times 1 and minus 44.8 times 1, right? Because they're now both indicator 1 and indicator 2. They're both 1s. So those two terms are in there. So now I'll need my calculator for that. So I'll take 71.9 minus 1.82, which got before was our 70.08, but now also minus 44.8. Gives us 25.28. So calories, get where I'm in here, get down here. Calories is 25.28 plus 0.212 times sodium. getting my U's and I's back with S. Okay, sodium. Okay, so notice what happened here. Notice in each case, let me get the different color here. Notice the slope didn't change, right? The slope didn't change. All I changed was the intercept. So for these models, right now what I have is, so for the beef, get my pen here. So for my beef, it's the highest slightly, right? So the beef is right here somewhere. Just below it, same slope, just 1.82 below it is the model for the meat, and those are parallel lines. And below that by quite a bit, right, that's another 44.8 below that, but it should be parallel, is the model for the type 3 for the poultry. So notice you got a problem here with at least one of the P's, right? We got a large P value here. So this model's got problems. So this so not quite the best place you want to be yet. So how do you make it better? Well, what we want to do next is you want to allow the slopes to change. Go let the slopes change. So the way you make the slopes change is you have to multiply the indicator variables by the x's. So you multiply the indicator variables by the other x's. Here, that's just sodium. We only have one other x. If you have more than one x, you have to divide by each of the x's. Here we have one x of sodium. So what I need to do is I need to go back to Minitab. So let's get back to Minitab here. Get back to our data. So now I want to create sodium times indicator 1 and sodium times indicator 2. I want to take two new columns, because that will now, since it's multiplied by sodium, that will now allow sodium to change, which will let the slope change. Okay, so to get the same as the handout, I call those in 1 times sod and in 2 times sod. Okay, so I'll give them the same names. So this one I call in 1 times sod, which in England's a bad word, but we'll ignore that. Don't want to teach you bad words. And over here we'll have indicator 2 in 2 times sodium. So all I do now is have to go to calculator, take sodium times the indicator. I know what's going to happen. All that's going to happen is if the indicator is 1, I'll have the sodium over here. But if the indicator is 0, I'll have 0 over here. So it's going to be zeros or the sodium values we're going to have in these indicators times sodiums. So we can use calculator to create those. So in the indicator 1 times sodium, I just take indicator 1 times sodium. Click OK. So those are the sodium values unless it is type 1, which is the beef, right? Because those are zeros. And now I go to calculator. In indicator 2 times sodium, I want indicator 2 times sodium. Again, those are zeros except when it is, in this case, type 3, right? Which is the poultry. That's the only one that's a 1 here for the indicator 2. So I created those. So now I'm just going to do the bad thing right now. Fit the whole model, show you what happens, And then we're going to say why we can actually do it a little better than this. So I'm going to go now, do stat regression, and fit the whole model. I'm going to do the categories with sodium, indicator 1, indicator 2, plus these two interaction terms. Indicator 1 times sodium, indicator 2 times sodium. So stat, regression. Categories are a response. Sodium, indicator 1, indicator 2, but now we also want the interaction. Put it here. We also want the interactions. Indicator 1 times sodium, indicator 2 times sodium. So I have 1, 2, 3, 4, 5 X's now. Click OK. What did I do wrong here? Let's try that. Oh, had it up here. There we go. I want some categories up there. I don't know how that got up there. I'm going to click that. Click OK. There we go. So here is the model. Here's the new model. Here, the checks the p-values, and we can notice right here, and we'll notice on the handout we've got problems, right, these p-values. But here's the model. R squared is 78.1%. Right here, R squared is 17.1%. Here's our model. Okay, so gets the pen here. So we used calculator to create those. Okay, so use calculator to create those interaction terms. Then we did a regression to get the model. Right, this is just using regression. So now we've got this full model, but again we've got problems here because we got way too many big p-values, right? Got way too many large p-values. So not the best model. I guess it could be, but it's very unlikely. Got way too many big p-values there. But let's first go ahead and see what this is telling us, and then we'll see what we can do to make it better. Okay, so I want to know what's the model for beef, meat, and poultry. So it's a little tricky because I need to get the still have the equation up here. So for beef, we know, let's go back to black here. We know for beef, it's 0, 0. So that means the indicators are going to disappear. So our calories is going to be 78.2 plus 0.196 times sodium minus 16.6 times 0, that's going to disappear, minus 37.3 times 0. And now, with the other two interaction terms, since it's 0 times sodium, it's going to be 0 still, right? So it's going to be 0.036 times 0 and minus 0.181 times 0. So those all disappear. And all we have is calories. Let's get a better calories there. Let's get a D there. Get a pen back. Okay. So calories is 78.2 plus 0.196 times sodium. Now the next one. Okay, so next we're going to look at the model for meat, right? So meat, we know the indicators 1, 0, right, in that particular order. So if we use the model, it's going to be what? Calories is equal 78.2 plus 0.196 times the sodium. That's the first part. Then it's what? Minus 16.6. And then this is what I'm doing here is I'm taking the 16.6 times indicator 1 And indicator 1 for the meat is a 1, so that's going to be a 1 here. Indicator 2 is going to be a 0, so that's going to be a 0 for the indicator 2. But now for indicator times sodium, indicator 1 is 1, so it's going to be 1 times sodium, so it's going to be 0.360 times sodium. Here indicator 2 is 0, so this whole last term is still 0. Okay, so that's what I'm going to do now. Let's go back down. So I have 16.6 times indicator 1, or 1, minus 37.3 times indicator 2, or 0, plus 0.0360 times 1 times sodium, so that's times sodium, minus 0.0181 times 0 times sodium, so it's times 0. So the indicator 2 terms disappear, but we still have the indicator 1 terms. So calories is equal to 78.2 minus the 16.6. That's the intercept, plus 0.196 plus 0.036 times sodium. That's going to be the slope. So calories is equal to, get the calculator out, so we want 78.2 minus 16.6. So it looks like we've got 61.6. So here we've got 61.6, and then I want to add to that, take the 0.196 plus 0.036, 0.232 times sodium. Let's scroll up a bit, get more space here. So now for poultry. For poultry, remember it's 1, 1 of the indicated variables, both being 1. So now what's going to happen is both these zeros here, which I had the zeros for the 37.3 and the 0.0181. This first one's going to be 1. The second one's going to be 1 times sodium, or we're going to have sodium in there. So it's going to be calories is equal to 78.2 plus 0.196 times sodium, then minus 16.6 times indicator 1, which is 1, minus 37.3 times indicator 2, which is 1, plus 0.036 times 1 times sodium, so that's times sodium, and then minus 0.0181 times 1 times sodium, because now it's indicator 2, so that's times sodium also. So now calories is equal to 78.2 minus 16.6 minus 37.3. That's our intercept, plus 0.196 plus 0.036 minus 0.0181 times sodium. So calories is equal to, so take 78.2 minus 16.6, which gave us that 61.6, but also now minus 37.3, which is 24.3. So that's the intercept. And now plus, we want 0.196 plus 0.036. 0.196 plus 0.036 gave us our 0.232, but we want to add 0.0181 if we want, but I put 0.0181. I guess we put the 1 into, so we get, let me try that again. I think that's off a bit. 0.196 plus 0.036, and then minus 0.0181. So that I get, if I round it to 3 decimal places, 0.3, not 3, erase that, 0.2, 13904, if I ignore that 1 there and just round it. Sodium. Okay, so now I have my 3 models. Here's my model for calories. Here's my model for the beef. Sorry, for the meat. Red is meat. And the beef is the black one, the first one. So this is the model. Let's make it a little thicker. This is the model for the beef. So what about those models? Well, what did we do earlier? Earlier, if I scroll all the way back up, I'm going to scroll all the way back up to our first models we haven't broken apart. Notice the models here. Here was the beef, here was the meat, here was the poultry. Do those look similar? Well, actually, if we go back and look, those are exactly the same models. So the models we got from type 1, where we just split it apart. We split the data apart, did them separately. Those are exactly the same models we have now. So if I scroll down, those are exactly the same models we have here. They're exactly the same. If I ignore that 1 here from the extra digit for the sodium, but same thing. So right now, so these are the same models we got earlier by just breaking up the data. Into the 3 types. So these are the same models. But it's not quite the same here. Because here the p-values give us extra information, right? But in this case, if we could look back at the p-values, we said that we had a problem with the p-values, right? Because they're big. But here we know the model is overfitted. But here we know the model is overfitted. It has too many x terms, right? Since we have some large p-values. So that's the extra information the indicator variables gave us. Since it kept us all as one model rather than breaking into 3 separate models, we now can see aha, we have problems. Maybe this isn't the best model to create. Maybe you can do something else. So that's the last thing we're going to look at here. We're going to go through it. I'm not going to worry too much about going through the mini tab, but all I did in mini tab is went back to best subsets. Did best subsets using all our 5 possible x terms. So I did stat regression best subsets for calories as my response with all 5. I guess I can show you, it's easy enough, right? All I did was said I wasn't going to do it when I do it. Stats regression. Oh, sorry, stats, not regression. Stat regression best subsets. Calories. Use all my 5 possible x's, sodium, indicator 1, indicator 2, and the indicator 1, indicator 2 is time sodium. And under options, just choose the best model of each size. Click OK, click OK. This is what I have on the handout. Just our best subsets. So best subsets, we know kind of how to do that, right? Best subsets tells us to look for the highest R squared adjusted. Because that penalizes if we have two terms of the model. And we want to look for where malloc CP is closest number of variables. So that looks like it's here, 4 and 4.1 looks like the closest, right? Difference there of only 0.1. So here, absolute value of 4.1 minus 4 is only 0.1. So that's the, for malloc CP. That tells us that's a possible good model. So here we have two possible good models, right? The model with only 2 terms, or the model with 4 terms. And actually, you fit the model with 2 terms, actually pretty good. So here's the model with 2 terms. So here the 2 terms are sodium and indicator 2. So here's the model with the X terms, sodium and indicator 2. And actually, if you do all the checks, we're not going to worry about it, but if you do all the checks, it is kind of the best model out of the group. So there's the model. Notice here all the p-values, you got good p-values. If we do the other checks too, it turns out the residuals look good and everything. We got a pretty good R squared. It explains about 78% of the variation. Remember, when we split the data up, only one of them, the beef one, had a high R squared. The other ones, meat wasn't too bad. It was lower than 77.8 though. It was like 74 point something. And the poultry was only 50% or so. So here we've got good R squared. It's a good model. The p-values are good. And what's it say about our data? Well, what's indicator 2? Remember what indicator 2 does? Let's go back up and check. So scrolling back up to the indicators. Indicator 2 was breaking beef and meat up from poultry. Beef and meat was 0, poultry or 1. So what this is telling us, go back down to it. So this tells us beef and meat are similar, which we can kind of see in the picture, while poultry is different. And all we're doing here, we only need to change the y-intercept. Get a better intercept there. Right, because that's all this is doing. Notice we don't have here, there is no indicator 2 times sodium term, which would change the slope. So here we've got the same slope for both models, 0.211, but we've got 2 models, one for beef and meat, one for the poultry. And the only thing that changes is the intercepts, the parallel lines here. So here, so the beef and meat model is just calories is equal to 71.3 plus 0.211 times sodium. And now that 45.8, for them it's 0, it disappears. So it's just calories is 71.3 plus 0.211 times sodium. Now for poultry, the difference is now that log is a 1 times that 45.8. So calories is equal to 71.3 plus 0.211 times sodium, but minus 45.8 times 1. And now that is going to change just the slope, right? We're going to subtract 45.8 from the slope. So if we take 71.3 minus 45.8, we get 25.5. So the final model for poultry is calories is 25.5 plus 0.211 times sodium. So for the beef and meat model, it is here somewhere, and for the poultry, all we've done is it's the same slope, just shifted. It's there somewhere. So this is our 71.3 plus 0.211 times sodium. And this is our 25.5 plus 0.211 times sodium. And that is the best model. Gives the highest R squared and gives us the best power, I guess, for the model. Okay, so that is how you deal with categorical variables. You can break it apart, but obviously we've seen you lose a lot if you break apart the categories and do them separately. If you keep them together, it's a lot more work. You have to do indicator variables, but you can get a better model doing it that way, and it is the best way to do it if you have the time and patience to do it that way.